Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into a fascinating paper showcasing surprisingly effective mathematical reasoning in a 7B parameter model trained with a mere 8,000 examples. It's all about leveraging reinforcement learning in a remarkably efficient way.
Wow, 8,000 examples? That's incredibly low compared to other models. What's the secret sauce here?
Precisely. The key is their surprisingly simple reinforcement learning approach, inspired by DeepSeek R1, but using PPO instead of GRPO. They bypass the complexities of reward models and SFT, focusing on a straightforward reward function based on answer correctness and format. Think of it as a very focused, efficient training regime.
So just a simple reward system. +1 for a correct answer in the right format, -0.5 for an incorrect answer, and -1 for no answer. That's it? It seems almost too simple to be true. I'm a little skeptical.
I understand your skepticism, but the results are compelling. They achieved 33.3% accuracy on AMI, 62.5% on AMC, and 77.2% on the math dataset, comparable to models using 50 times more data. They even observed the emergence of self-reflection in the model's responses, a phenomenon also seen in larger models.
Self-reflection in a 7B model trained on just 8K examples? That's mind-blowing. Can you elaborate on what that means in this context?
Sure. It means the model started showing evidence of checking its own work and reasoning process, almost like a human would. They illustrate this with an example in the blog post, a screenshot showing the model's step-by-step reasoning and self-correction. It's a clear indication of emergent behavior.
Fascinating. So they experimented with two approaches. Simple RL0, training directly from the base model, and Simple RL, adding a long context SFT, supervised fine-tuning, step beforehand. What were the differences in performance?
Simple RL0, the direct RL approach, already yielded impressive results, but Simple RL, with the SFT warm-up, showed even better performance on some benchmarks, surpassing even the EURUS 2-7 B-prime model in certain cases. However, the improvement wasn't as dramatic as one might expect, given the use of a much larger 32B model for distillation in the SFT stage.
That's interesting. It suggests that the Simple RL approach itself is incredibly powerful, even without the SFT pre-training. Perhaps the SFT data wasn't perfectly aligned with the smaller model's capabilities? Or maybe the RL training overrode some of the SFT's learned patterns?
Exactly. They observed a temporary decrease in response length at the beginning of the RL training in both scenarios, suggesting the model was discarding less efficient reasoning patterns learned during the SFT stage, or even in the base model, and then developing its own more effective strategies. It's a testament to the adaptability of RL.
This research really highlights the potential of simple, efficient approaches in achieving remarkable results. The fact that they've open-sourced their code is also a huge contribution to the community. It opens up exciting possibilities for further research and development.
Absolutely. This work challenges the conventional wisdom that massive datasets and complex architectures are always necessary for advanced reasoning capabilities. It's a powerful demonstration of the potential of reinforcement learning, especially when combined with a well-designed, albeit simple, reward function. And that's all the time we have for today. Thanks for joining us on Tech Bytes and News. Goodbye.
Bye-bye.